In this lesson, we are going to learn about linear inequalities and how to graph them. We are going to work in section 1.7 out of your textbook on pages 141 to 142, and we're going to work problem numbers 2 through 76 even. Before we start, we need to learn a little bit of terminology. If we've got this symbol here, that means less than. This symbol here means greater than. And this symbol here we know is equal to. Over here, you see we have a less than symbol, but there's also a line under it. That means less than or equal to. And it might be a little hard to see with how I drew the symbol, but this one says greater than or equal to because you have that greater than sign on the top. All right, so on problem numbers 2 through 8, they're asking us to complete the statement using the symbol less than or greater than. So we have to determine which number is smaller and which number is bigger. So between the numbers 9 and 8, we know that 9 is greater than 8. If it helps you, you always want this open end to be facing whichever number is larger. That helps you at all. Number 4, we're going to compare 0 and -5. Well, I'd much rather have $0 than owe somebody $5. So having 0 is greater than owing 5. Okay, now looking at problem number 6, we have -10 and -5. If you think about this on the number line, guys, sorry, it's not straight. You'll see that you have a number line like this. As you go to the right, your numbers get larger and they're positive. As you go to the left of 0, notice your numbers are negative and they get smaller. So if we look at these negative numbers on our number line, if we keep going, our next number is 5 after the 4. And then we're going to have to go a couple more spaces to get to the -10. So that means that -5 is greater than that -10. And if you read it from left to right, it would be -10 is less than -5. Okay? You can also think of it as money. If you owe somebody $10 and I owe somebody $5, well, technically I have more money because I don't owe somebody as much as you do. I don't have as much to pay back. And then problem number 8, we have -4 and -11. Think of it the same way with the number line. The next number right after -3 will be -4, and then you have to go a ways to get to -11. So -4 is going to be larger than -11. All right, now on problem numbers 10 through 14, they're asking us to write each inequality in words. So we're going to start off on number 10. Sorry about that. And we're going to say x is, this symbol is less than, if you look at the notes from earlier, less than or equal to. And the number is -3. If you want to write out -3 in words, that's okay. It's not a big deal, at least for me. Okay, so now let's look at problem number 12, and I apologize if y'all can hear all the shouting in the background. I have to keep my office door open and people are loud. All right, so looking at problem number 12, we have x is, this symbol is less than, and the number we're comparing is -2. Okay. Now on number 14, we have the number 2, and that symbol is also less than, and we're comparing that to x. All right, so now on the next couple of problems, 16 through 28, we are going to learn how to graph these inequalities. So real quick, I'm going to pull the paper back down so we can see this little quote unquote chart that I've drawn. So whenever you see a less than or a greater than symbol, like these two here, you need to keep in mind open circle. When you see a less than or equal to or greater than or equal to, you need to think closed circle. If it helps you, you can think of, you have to use more ink to draw the equal to part, so you need more ink to color in the circle, if that helps you. In your book, you will notice that for less than or greater than, the book uses parentheses. And for less than or equal to and greater than or equal to, they use brackets. So the reason I don't use parentheses and brackets is because you can draw some pretty convincing pictures of parentheses and brackets that could possibly pass as both. So with my method, with using the open and the closed circles, there is no disputing whether that circle is open or closed. It should be very evident. All right, so let's actually look at problem number 16. We have x is less than -3. So the first thing we need to do is actually put numbers down here on our tick marks. You must have at least 3 points on your graph for me to accept it. I'm going to write it down because it's so important. Okay. All right. So one of the numbers that we're going to have to use on our number line, normally students tell me 0, but that's not the case. 0 doesn't have to be on a number line. You're just used to seeing it on a number line. The number we absolutely have to have on here is that -3, because that's what we're comparing x to. You can put it in any one of those tick marks. It really doesn't matter. For simplicity's sake, I'm going to put it in the middle. So now you have to fill in the other 2 tick marks. I don't accept it if you do not, so make sure that you do. So when we look back at our number line here that we did earlier, the number that comes immediately to the right of -3 is a -2. So this would be a -2. And then if we were to go one more number to the left, notice it was -1, -2, -3. Next number after that would be a -4. Okay? So now, notice we have a less than symbol, and it says in our chart up here, whenever we have a less than or greater than, we're going to use that open circle. So we're going to put an open circle on that -3 tick mark. Now, the problem says x is less than -3. If something is less than, that means that it is going to be smaller than. Okay? So if you think about a number line, this way your numbers get bigger, this way your numbers get smaller. So we're going to shade to the left because that is where x would be less than. So it's saying that any number that is smaller than -3, but it doesn't include -3, will make this a true statement. Okay? Another way you could do this, it's a little shortcut way, when x is on the left, I'll say it one more time, when x is on the left, you can take this little less than sign and you can draw a line through it, and that tells you which way you're going to shade. Notice that our inequality sign is pointing to the left, and we shaded to the left. Now our graph is complete. So looking at number 18, we have to include the number 4 because that's what we're comparing x to. So I'm going to put a 4 right here. The number that comes to the right of 4 is 5. And the number that comes to the left of 4 is 3. If you have a problem coming up with these numbers on your own, then you can feel free to draw a number line on your test. I don't care if you draw a number line that outlines the entire perimeter of your paper. If that helps you, that is not a problem with me at all. So I'm going to use an open circle because I used a greater than symbol, and at the top of our paper, remember we wrote that less than and greater than have an open circle. And then it says that x is greater than 4. Numbers that are greater than are going to be this way, so I'm going to shade this way. That means that every number that is to the right of 4 on this number line is going to be a solution if we plug it in for x. Okay, again, you could have also done that shortcut where you drew a line through that and you drew to the right. Problem number 20, we have x is less than -2. So we have to have -2 on our number line. The number to the right would be -1. The number to the left would be a -3. You have to get these numbers right to get the problem right, guys. Please make sure that you are paying good attention to that. Okay, so it's going to be an open circle because it's just a less than sign. And it's going to be shaded to the left. Okay, so looking at problem number 22, I have x is greater than 3. So we have to include 3 on our line. Remember, you could have put it on either one of those tick marks. I'm just putting it in the middle to make it easy. The number before 3 is a 2. The number after 3 is a 4. So we're going to use an open circle on the 3. And we're going to shade to the right because it says x is greater than 3, and our arrow is pointing to the right. Okay, 24, we have a -2 we're comparing x to. The number before that is a the number to the right of that is a -1, and to the left of that is a -3. So if x is less than -2, we have to use an open circle, and it tells us we're going to shade to the left. Number 26, x is greater than or equal to 0. So we're going to actually put 0 in the middle this time. 1 is to the right, -1 is to the left. And we're going to use a closed circle this time. The reason we're using a closed circle is because that equal sign under the inequality. Up here on these other two, they didn't have that. So this is a closed circle, and you are going to shade to the right because it says x is greater than or equal to 0. So that means that any of these shaded numbers to the right of 0, including 0 this time, will give us a true statement for number 26. Okay? Problem number 28, we're comparing the number -3. We have a -2 this way and a -4 this way. So it says x is less than or equal to -3. Well, we're going to use a closed circle. Remember, it's because of that equal to. And we're going to shade to the left because it says it's less than. It's going to be where all the smaller numbers than -3 are. All right, so on number 30 is where they're going to start making us work. On number 30, they give us x plus 5 is less than or equal to 4. The directions tell us to graph the solution set of each inequality. Before you can graph this, you have to have the x by itself. Okay? So what is in the way of x being by itself is that 5. And you can imagine, I don't want you to change it, but you can imagine that right here is your equal sign, and this dotted line represents your left side and your right side. So if we were to solve this, you do the opposite that's being done to x. So the opposite of adding 5 would be to subtract 5. Which leaves us with x is less than or equal to -1. We've got 4 minus 5 is -1. So -1 is going to go in the middle of our graph. 0 is to the right. -2 is to the left. We're going to use a closed circle on the -1. And we're going to shade to the left. Okay, problem number 32. Again, we're going to imagine that that line is there. And on 32, we're going to need to add 11 to both sides, which gives us x is greater than -3. So I've got my -3, -2, and -4. So I'm going to use an open circle on my -3, and I'm going to shade to the right. And remember, that arrow trick only works when x is on the left. So really make sure that you don't forget that part. Problem number 34. Okay, so remember you have to have all your x's on one side, so we need to move one of these. We're going to end up moving the smaller x, so we're going to subtract 7x from both sides, which gives us x, because 8 minus 7 is 1x, is greater than or equal to -4. So I'm going to use -4 for one of my numbers, -3 over here, -5 over here. I'm going to use a closed circle, and I am going to shade to the right. Okay, So now on 36, we're going to subtract 2x from both sides because we want to keep our x positive. So we move the smaller of the x's, which gives me x plus 2 is greater than 0. And then to get x by itself, you're just going to subtract 2 from both sides to get x is greater than -2. So I'm going to put my -2 in the middle, -1 to the right, and my -3 to the left. That's a 3. And if I use my greater than symbol, I'm going to have an open circle, and it's going to shade to the right. All right. All right, for problem number 38. So we need to move the smaller x first, which is my 4x. So 5x minus 4x is x. Bring down your 2. Bring down your less than or equal to, and you have a -6 because those 4's are going to cancel. Add 2 to both sides to get x is less than or equal to -4. We're going to put our -4 on our number line. Got a -3 here, -5 here. We're going to have a closed circle because of that equal to sign down here, and it's going to be shaded to the left. All right, for problem number 40, we are going to subtract 7x from both sides to get x minus 7 is greater than 3. And then we're going to add 7 to both sides to get x is greater than 10. So 10 in the middle, 11 on the right, 9 on the left. We're going to use an open circle, and it's going to shade to the right. Okay. All right, don't let these fractions scare you on number 42. So this -1/8x is smaller than 7/8. So I'm going to add 1/8x to both sides. So 7/8 plus 1/8 gives me 8/8, which is just 1x, plus 6 is less than 3. Subtract 6 from both sides to get x is less than -3. Okay, so I'm going to have an open circle on -3, and I'm going to shade to the left. We are not going to do problem number 44. That problem has a bunch of decimals in it. We have not learned how to work decimals in this class. It is unfortunately not in the curriculum, so I'm not going to confuse you further by having you work any of those. So moving on to number 46, we have 5x is greater than 20. So I'm going to divide both sides by 5, because the opposite of multiplying x by 5 would be to divide. So that gives us x is greater than 4. So I'm going to put my 4 here, 5 here, and my +3 there. An open circle on the 4, and I'm going to shade to the right. And then on number 48, oops, sorry about that, guys. And then on number 48, we're going to divide both sides by 6 to get x is less than or equal to -3. -3, -2, -4. I'm going to have a closed circle on number 48, and I'm going to shade to the left. Okay, so moving on to problem number 50. All right, here is where the final trick comes into play in this section. So here we're going to have to divide by a -9 in order to get our x by itself and to be positive. Whenever you multiply or divide by a negative number, you have to flip the inequality sign. I'll say it one more time, then if you need it, you can rewind. Whenever you multiply or divide by a negative number, you must flip the inequality sign. So when we divided by that -9, that gave us x, and instead of less than, we're going to flip it to be a greater than. 45 divided by -9 is -5. Okay? -5 is here, -4 is here, and -6 is here. And we're going to have an open circle, and we're going to shade to the right. So now on number 52, we are going to divide by a -12. And that leaves me with x is, notice that we divided by a negative number, so we have to flip that inequality sign. So instead of having a greater than or equal to, we now have a less than or equal to. -48 divided by a -12 is a +4. So I'm going to label my tick marks. I have a closed circle on my 4, and I'm going to shade to the left. Okay. Now number 54, we have x divided by 3 is less than or equal to -3. So we are dividing x by 3. So the opposite of dividing x by 3 would be to multiply by 3, which gives us x is less than or equal to -9. Notice how I did not flip the inequality sign. The rule is when you multiply or divide by a negative number. Here I only multiplied by a positive number, so we don't flip it. Only when you multiply or divide by a negative number. So I have my -9, -8, and -10. Closed circle on the -9, and I'm going to shade to the left. '56. Notice how in the book it was written with the negative sign in the middle. I chose to put the negative sign with the 4 so my x would already be positive, because that's my whole goal. So I'm dividing x by -4, so the opposite would be to multiply by -4. So since we multiply by a negative, we're going to have to flip that inequality sign. So instead of having a less than, we have a greater than. 5 times -4 is -20. So I have my -20 here, -19, -21. I'm going to put an open circle on my -20, and I'm going to shade to the right. Problem 58. Well, let's get rid of the denominator first. So we multiply by a 4, and it was positive, so we don't have to flip anything. Leaves us with 3x is greater than or equal to negative 36. Now we divide by 3 to get x is greater than or equal to negative 12. So negative 12, negative 11, and negative 13. I'm going to have a closed circle on my negative 12 because there was that equal sign, and I'm going to shade to the right. On number 60, I need to get all of my x's on one side, so I'm going to move this smaller one here. So I subtract x from both sides to give me 3x is less than or equal to negative 9. Divide both sides by 3 to get x is less than or equal to negative 3. Remember, we only flip when we multiply or divide by a negative number. So my negative 3 goes here, my negative 2 here, my negative 4 here. So I'm going to do a closed circle on my negative 3, and I'm going to shade to the left. Okay. Number 62, I'm going to move my 2x over to the left side because it's my smaller x. So I'm left with 5x, bring down your 3, is greater than or equal to 0. Okay, we're going to subtract 3 from each side, and then we're going to divide by 5. Okay, so we get x is greater than or equal to negative 3 over 5. Guys, I'm not going to give you one that is going to be this hectic for plotting on your number line, but what you can do, put your negative 3 over 5 here, and imagine it was just a negative 3. If so, you would have a negative 2 here, a negative 4 here, and all you have to do is put them both over 5, and you have it correct. So again, I'm not going to give you one that crazy. So we're going to put a closed circle on our 62, and we're going to shade to the right. Okay. On 64, we subtract 5 from both sides to get negative 3x is less than or equal to 12. Divide both sides by negative 3 to get x is. Now we divided by a negative number, so when we divide by a negative or multiply by a negative, you have to flip that sign. So instead of writing less than or equal to, we're going to write greater than or equal to. 12 divided by negative 3 is negative 4. So label your tick marks. It's going to be a closed circle on negative 4, and we're going to shade to the right. Problem number 66, we have our 3x is less than 7x minus 28. I'm going to move the 7x because I always want the x on the left. Normally, if we were working an equation, you would always move the smaller x, but since this is an inequality and we always want the x on the left, I'm going to move everything to the left. So that gives me a negative 4x is less than negative 28. Then we divide by negative 4. Remember, when you divide or multiply by a negative, you flip that inequality sign. So that's now a greater than, and we have 7. So label your tick marks, and it'll be an open circle shaded to the right. Okay, number 68, I'm going to add 12 over 7x. So 3 over 7 plus 12 over 7 gives us 15 over 7x plus 6 is greater than or equal to negative 9. I'm going to subtract 6 from both sides to get 15x over 7 is greater than or equal to negative 15. So I'm going to multiply by 7, which gives me 15x is greater than or equal to negative, I want to say 105. Yep. And then you divide by 15. So x is greater than or equal to negative 105 divided by 15 is negative 7. So it's going to be a closed circle on the negative 7. And I'm going to shade to the right. We are also not going to work because it was a problem that had those big old decimal numbers, and we don't learn those in this class. 72, we're going to subtract 2x from both sides, which gives us 3x minus 2 is greater than or equal to negative 7. Add 2 to both sides to get 3x is greater than or equal to negative 5. Divide both sides by 3 to get x is greater than or equal to negative 5 over 3. Again, put your negative 5 over 3 in the middle. And think of it this way. The number before, to the right of negative 5 is negative 4. To the left of negative 5 is negative 6. And keep them all over the same denominator, and I'll accept that. Okay? It's going to be a closed circle on negative 5 over 3. And we're going to shade to the right. Okay, so again on 74 I'm going to want to move my x's over to the left. It'll make it easier when we go to graph. So negative 5x minus 3 is less than or equal to 27. Add 3 to both sides to get negative 5x is less than or equal to 30. Divide both sides by negative 5 to get x is less than or equal to negative 6. But what did I forget to do? Since we divided by a negative number, this should have swapped. So it should be x is greater than or equal to negative 6. So I plot my negative 6, negative 5, negative 7. It's going to be a closed circle on the negative 6, and we're going to shade to the right. Okay, so for the last problem here, I'm going to subtract 8x from both sides, which gives me negative 6x plus 3 is greater than negative 2. Subtract 3 from both sides to get negative 6x is greater than negative 5. We're going to divide both sides by negative 6 to get x is less than, remember you have to flip that inequality sign, and that's a positive 5 over 6 because a negative divided by a negative is a positive. So I have 5 over 6. If I look at just the 5, the next number would be a 6. Number before it would be a 4. And put them over the same denominator. I'll accept it like that. Open circle on the 5 over 6. And you're going to shade to the left. Okay. I hope this video has helped you, and I wish you the best of luck.